Okay, this is the Arborist call for the 22nd of August, 2024. We're going to start off with core team updates, and then we'll have our research and implementation updates. And I think it's going to be a full schedule today. So let's try and be respectful of the schedule and of people's time. And then we'll move on to open announcements and open discussion if we have time for it. What are Arborist calls? These are calls that we hold every 2 weeks in alternating early and late slots in order to cater for as many people's time zones as possible. And it's where contributors to the Zcash protocol come together to discuss and coordinate on upgrades and improvements to the protocol. The idea of having these calls and of making them open to the public and of recording them and uploading them to YouTube is to make sure that the Zcash community at large can have a visibility of how the Zcash protocol is developed and how the sausage manufacturing works. Anybody who wants to can join these calls. You just need to go and register at zcasharborist.org. And if you'd like to propose a topic for discussion, then you can do that by dropping an email to arboristcall@zfnd.org. Other ways to get involved in Zcash are you can request a community grant. You can also join the R&D Discord, which is where most of the engineers who work on Zcash hang out and spend their time coordinating. Or you can join the always spicy and exciting and opinionated Zcash community forums. And you can find all of these links by pointing your browser at zcasharborist.org. So let's get started off with core team updates. And let's start off with an update on where we are with NU6. I'm not sure the best person. I think probably Chris might be the best person to provide an update on this.
Yep. So we have just this morning finally released have a release PR for Zcash T510 RC1. We are now at long last ready to proceed with private testnet testing for NU6. And the main blocker that we faced there has been, as with many things in Zcash D, there's a fair bit of bit rot in the RPC tests for the Zcash node that caused us a fair bit of rework that we weren't expecting in the process of getting out both the NU6 lockbox changes and the changes that require all blocks to fully balance. So one of the features that was accepted by the zip editors for NU6 is that it will no longer be allowed for miners to fail to claim all of the fees from transactions. This hasn't been an issue in a long time. Miners have generally been using the Zcash and ZBRD block construction that does claim all fees. But early in Zcash's history, there were a bunch of fee values that were left unclaimed, and forcing the blocks to balance has been something we wanted to do for a long time. And as an added benefit, forcing the blocks to balance helped us discover a bug in our implementation of the NU6 lockbox changes. So that's positive. The other thing that has been a major focus of the ECC core team in the past couple of weeks has been in the Zcash client backend and Zcash client SQLite. We now have full support for transparent wallet history recovery, which is a pretty important step on the way to replacing the Zcash D wallet. So previous to this, essentially transparent parts of the transparent protocol was only partially supported by the wallet backend. It was possible to get unspent outputs and to shield them, but not to recover any transparent history that might have come from a fully transparent wallet, or importantly from the Zcash D wallet, which might have fully transparent history. So we now are able to to properly traverse the transparent history associated with your wallet, and that's the next big step on the way to ZHD wallet replacement. The other piece that that has gone in there is in the process of going in is that Greg File, who came on with us as a came back to us as a contractor recently, has been making good progress on updating Sean's work to fully support transparent script functionality in Rust. So there are a couple of PRs that are open against the Zcash script repository that provide a generalized Rust interface for evaluating transparent scripts, and we're now in the process. Is now in the process of using that to start doing some property testing to compare the C++ script interpreter against the Rust script interpreter. So good progress on that front. So for those of the ZF who are interested, reviewing those PRs that are open would be helpful. And that's going to be one of our focuses in the next week or two, is pushing that transparent script replacement functionality forward.
Chris, whenever you can, may you share the links to those PRs, or are they easy to locate by name?
They should be easy to locate by name, just on the
Awesome.
Zcash Foundation /Zcash script repository. I think one of them is in draft and one of them is should be ready for review.
Tomek?
Yeah, I just want to point out that because Chris, you mentioned that one of the changes in NU6 is going to be that it will not be possible to not claim all the miner rewards. I just want to point out that in zip 233, which is the ZSF zip, basically all the previously unmined, all the previously unclaimed miner rewards will become part of the ZSF. So the zip 233 doesn't specify if I think it doesn't specify if that will only apply to past blocks or future blocks as well. So I guess this is something that we'll need to figure out if we, because
Well,
I think the original intent in zip 233 was that not claiming all the miner rewards will be the way for miners to donate to the ZSF.
We should.
well, there will be a ZSF deposit field.
Yeah.
So
Yeah, we should
Yes,
That's
there
how
will
they should
also
do
be
it.
that. Yes.
and be explicit rather than making it implicit. Part of
Yeah.
the problem is that by having things like the ZSF deposit and then also the transaction fee be implicit, that where you have to actually explore the chain, that makes it much harder for example, hardware wallets to verify that the fee being paid is correct, or that the ZSF deposit is being is correct. Whereas if we have this rule that that transactions must balance and that blocks must balance, then there's no ambiguity, and all of the relevant affecting information of the transaction can be verified by the hardware wallet.
I mean, to be fair, the ZSF deposit would be an explicit field in the transaction, and so it would be committed to by the successor to ZIP 244. So
Yeah,
it's not
yes,
really any
absolutely,
problem there.
absolutely. But
I
still
agree with the
still
general
a balancing
principle.
rule, because otherwise,
yes,
the
of course we
wallet
do.
doesn't have all the information.
Yeah, I mean, I suggested it
Yeah.
partly for that reason. So
I mean,
I think
also
maybe-
agree, and I also agree with the sentiments that it's better to be explicit, but just to point out that that was the original design, to be explicit, and then
I mean,
then it was...
there's nothing really to specify here, because there will be no unclaimed rewards in future, and so it doesn't matter whether the specification says to that those go into the CSF or not, because they will be zero.
Yeah, I mean, it matters in terms of the specification regarding previously unclaimed funds.
Yes, of course.
As part of the ZSF, but
Yeah, and I was going to say, I think maybe what Tomek was getting to there is that the way we define the ZSF is in terms of the max, max value versus the current chain value. So if you just take the difference between those two, that will include any previously unclaimed transaction fees. So if we go with that definition, then we're kind of automatically scooping up those previously unclaimed fees as part of this.
Noted. Yeah.
I do feel like this is straying a bit away from the current topic, which is NU6. So any further questions relating to NU6 specifically? Do we have a timeline for testnet activation?
So what we would like to do is today collaborate with the ZF engineers to run a private testnet where we activate on the private testnet, just to make sure that activation goes smoothly and that we can test across that activation and mine blocks across the activation. And then once we've done that, then we can set a public testnet activation height.
Can somebody from ZF volunteer to take point on arranging
And we have
coordinating
already
that?
have a private Discord channel set up that we've been starting to discuss this. So I think we're on the same page there.
Cool. So are we hoping to have testnet activation early next week, perhaps?
We'll discuss it once we've done some testing.
Yes.
Makes sense. So one of the issues is that we do need time for some portion of the testnet nodes to be upgraded to the latest release before we can, otherwise we'll just have a testnet fork. So let me look quickly. I believe that Zcash D5.9 reaches its end of service halt in early September, I think like September 8th or September 9th. So to be fully safe, we would want the public testnet activation after that. But
I don't think it really needs to be after that.
Not necessary. There'll just be a testnet chain fork that people have to be aware of what nodes they're using for testing.
Yeah, I don't think it. So we enforce that policy for mainnet, but I don't think we need to for testnet, because anyone who is actively testing on testnet is hopefully more aware of updates.
Okay. Any other questions or points relating to NU6?
Oh, and also I think that on testnet, does it even obey the EOS halt?
Oh, that's a good point.
Can't remember. I don't think it does, because the heights are all different.
Yep. Yeah.
The EOS heights are mainnet heights. Yeah, so that's not an issue.
Paku?
Oh yeah, just bringing up that maybe people running infrastructure that are not actively testing may need a heads up just in case for the testnet activation. But yeah, that's all. I can help with that, or just take care of it, and it's just like,
Thank you.
so you don't have to.
Thank you.
Just let me know and I'll message to people.
And Tomek is asking if the testnet setup that would include Zcash D and Zebra nodes, is it documented anywhere?
So a good way to, just give me your Discord username and I'll include you in the private NU6 testnet activation channel. And then we can, I suspect that we're going to work out a bunch of issues in this process, and we'll document all of that as we do this joint effort to activate on private testnet.
Okay. Anything else relating to NU6? Okay, let's move on to Zebra updates. And I can't remember whether it's Aria or Alfredo who's in the hot seat today.
It's me today.
Oh, okay.
Oh, okay. Well,
Go ahead.
so in Zebra, since the last Arborist call, we have merged error handling for block subsidy calculations to avoid panics at low block heights. Coinbase transactions must balance exactly after NU6. Major database format versions can now be restored from state caches using the previous major database format version. So Zebra no longer needs to resync the whole chain from scratch when its major database format version has been bumped. The latest changes to Libra Zcash dependencies are being pulled from the main branch in Libra Zcash to ensure a smooth transition to their next release. Thanks to Strad for the suggestion and Alfredo for the change. The debug output for the testnet variant of Zebra's network type has been reduced to reduce noise in Zebra's logs when running on testnet. Zebra's get block subsidy RPC method has been updated to return information about lockbox streams when NU6 is active. The get block chain info RPC method has been updated to return information about chain pool balances at the chain tip. Zebra's open API spec was updated to reflect the changes in those RPC methods, and the minimum required protocol version when NU6 is active has been updated to align with the NU6 deployment zip. And there were also various documentation updates and fixes. There are currently PRs open for moving common dependencies of multiple crates in the Zebra workspace to workspace dependencies, thanks to Tomic. Ignoring Coinbase spends must be shielded rule on regtest. Using the new scripts trait in Zcash scripts, thanks to Greg. There's also one in Zcash scripts for this, and then running possible minor database format version upgrades before attempting to restore state cache from the previous major version. So in-place upgrades work correctly on long outdated state caches and will work correctly in the future if Zebra's major database format version is bumped shortly after a prior version of Zebra has bumped the minor version. Returning verification errors from the send raw transaction RPC method, thanks to Han for bringing it to our attention. Writing the database format version to disk atomically to avoid a panic in rare cases where it could be malformed or corrupted, like due to a poorly timed interruption. Updating Zebra's end of support hold time on mainnet to fall before the expected NU6 activation height on mainnet. And finally, there's a PR open to update the changelog and prepare for the release of Zebra 1.9, which is ready to deploy NU6 on testnet. There's also been a little bit of preparation for running Zebra nodes on a private testnet to manually test its NU6 implementations in coordination with the ECC, and some minor preparation for an audit of the NU6 changes ahead of mainnet activation. And I think that's it for Zebra.
Any questions relating to Zebra?
Yeah, that was quick. Did you say that you fixed the issue reported by Han like the last few days? Or I heard wrongly.
No. So we did start returning those errors in a draft PR. So if a transaction is not verified and added to the mempool, the send raw transaction RPC method will return the error explaining why. But it may not be propagated through Light Wallet D because we also need to make some changes in Light Wallet D, and it hasn't yet been merged into main. So you have to use the branch in order to get those errors currently.
So does this mean that Zebra is behaving more like Zcash D in this respect? So in theory, the same change to Light Wallet D will work for both Zcash D and Zebra?
Yes, in the sense that it's at least returning the errors. No, in terms of like the format is slightly different, but I think we should update that in Zcash D.
Okay.
Oh, and
that makes sense.
And is the change in Light Wallet D being worked on, needs to be worked on? Does he have an issue? Or is it done already?
Sure. I don't know if it's being worked on. Chris, do you know?
Okay, so there are a couple of different issues on Light Wallet D. The one, so Larry Ruan is going to be working on correctly propagating errors from the Zcash D RPC and Zebra D RPC APIs as gRPC errors, and then separately there was this issue with being able to specify get the issue with the get raw transaction that I've already merged a PR for. So did I get everything there? Sorry, I was distracted by other discussion.
Cool. Yeah, I found the issue, Larry.
Sorry,
Open. I pasted it in the chat.
Sorry, repeat the last thing. I didn't hear.
Oh, the last thing was the incorrect propagation of the block height information for
yes.
Got
it.
mempool and orphan transactions. So those values were not being properly propagated via Light Wallet D. The other thing there is that, so part of the reason that they weren't being properly propagated is that the protobuf definition was actually, unfortunately, it used a uint64 instead of an int64 for block heights, and that means that we have to map the negative block heights that are used to indicate orphan transactions in the Zcash D RPC responses to the max block height or the max value of uint64. So that's just a wart that we're going to live with in the Light Wallet protocol. But at least it will now be propagated properly, whereas before it was not even being parsed properly. Or it had platform dependent behavior.
So we assumed that it was supposed to be 64-bit instead of platform int. There was something else I wanted to say. Oh yes. So if we have a better idea of what needs to change in Light Wallet D to make sure that errors are propagated synchronously when they can be, can we make sure that that's documented in a Light Wallet D issue? I know it's already documented in.
Yes, that's the issue that that Paku just linked, 497.
Oh, sorry. Yes, I didn't see. Perfect. Yeah.
Alfredo.
Cool.
Yeah. So in addition with what Arya said, which was a lot more than I had in mind to give Zebra updates. So thank you, Arya. We also tried in the RPC methods to add the value pools to the get block RPC method, but we realized that ZBRD doesn't keep track of the value pools for specific blocks, but just for the tip. So we discussed it with the ECC people, and we think that's not totally needed. So ZBRD will not have that. We'll have get block subsidy and get block chain info to get information from the logbox, but not for a specific block with get block. So that's one thing that we tried to do, but we ended up deferring it. Another thing we did is that we investigated 2 security fixes, denial of service in the Zcash protocol that were backported from Bitcoin to Zcash D. Our initial conclusion, and maybe we should write a statement about it, is that ZBRD is not affected by the 2 of the issues that Zcash D backported. That's it.
Cool. Thank you.
Any other questions regarding Zebra? Okay. Let's move on to ECC and the various products that they are currently working.
Yeah, I can do this. So we're just on the verge of releasing Zcash D 5.10.0 RC1. Just waiting for the PR to finish CI. And that will include so the two security fixed backports that were just mentioned, and NU6. So all of the consensus changes for that are, so the activation heights are not set, but all of the consensus rules are implemented and have tests. We also fixed a bunch of, well, not all of the unreliable tests, but some of the unreliable tests, just to get the PRs through. Let's see. We've updated the Zcash D's dependencies on Rust crates. What am I forgetting?
I gave a bit
It
of
does-
this report before you arrived
Yeah.
on the call as well.
Yeah, it does. So it does not include the reduction of the default unpaid action limits to 0. We couldn't get that in time. Yeah, I don't think there's anything else.
Yeah, with respect to Zashi and the wallet SDKs, we've just released both Android and iOS version, and I think in both cases it's version 2.2.1 of the ECC wallet SDKs. There is a new Zashi iOS release that has just hit the app stores this morning, and there will be a Zashi Android release that hits the app stores well, as soon as Google gets around to accepting the newest release into the Play Store is basically what it comes down to. So those new Zashi releases include currency conversion with currency value fetched over Tor from multiple exchanges and taking the median. So it's possible to get currency conversion rate information without having to reveal your IP address and your interest in Zcash to the exchange servers. It includes TEX address, so ZIP320 support. And as part of ZIP320 support, as I mentioned earlier, we ended up having to essentially implement support for fully transparent wallet history. And so the SDKs now will recover all fully transparent wallet history as in addition to the shielded history that they already properly managed. So the text support ended up taking us a bit longer than we anticipated because we realized after having fully implemented text address spending that we weren't getting complete wallet history back, and so we had to implement all of the fully transparent wallet history support that we had thought we were going to be able to put off till later. So it just sort of reprioritized that in the release process. But as I mentioned before, that's all pretty important for Zcash D deprecation. So we made a bunch of progress there.
Yep.
Any questions relating to ECC's work? Okay, I think we kind of covered off. Well, other than what we've already discussed, I don't think there's anything else going on the Zcash D deprecation front at the moment, is there? Primary focus has been on NU6.
Yep.
Alfredo?
Yeah, I think there had been some progress in regards to running the RPC test that Zcash D has with Zebra as the backend. Immediately after Chris kind of started doing that, found some issues. So I guess that will be a path that we'll follow forward to, regarding Zcash D deprecation.
Yeah, that effort to it's we've done a lot of cleanup on the RPC tests as part of the NU6 release, just in order to, you know, address some of the bit rot that I mentioned earlier. But one of the things that we will really want to do with the Zcash deprecation process is see what we can do to get the RPC tests running against ZBRD. We expect that a lot of them will likely fail either due to you know, issues with you know, issues with the RPC tests being very you know, highly tied to the expectations of what Zcash D is providing, but it'll at least get us to where we can do kind of a side-by-side comparison of how Zcash D and ZBRD are responding to the same RPC requests, and then eventually we'll be able to replace, you know, as we start replacing the Zcash D wallet, then we can try to get all of those RPC tests passing against both nodes, and that will be a huge step forward in Zcash D deprecation.
Cool. Paco.
All right. Cool. Yeah, well, first, congratulations for the SDK release. It's a huge feature to have good transparent support on the SDKs. And yeah, regarding Zcash deprecation, I just wanted to chip in that given that my grant has been repurposed a bit and on its goals, and it has thankfully been extended for the next year, that I'd like to just bring it up that anything that I can, whatever I can do to help in Zcash deprecation, I think this is the most important thing that we have besides NU6 at the moment. So anything that I can contribute to make this happen smoother, or like get stuff that off your shoulders from the Zebra team or for the ECC team, I'm pretty glad to do it. So just come in on anything I can help.
Cool. Thank you, Paco.
Thank you.
Right, moving on to research and implementation updates. Let's hear from the, I'm guessing it's Tomek and or Paul to talk about the Zcash Sustainability Fund.
Yeah, I can give an update. So the Zebra code has really been in a almost finished state for about a month. We haven't pushed it yet. We've been struggling with testing it in integration a little bit. We as I mentioned in the chat, now we've tried to set up a test net with Zcash and Zebra nodes and send some ZSF deposit transactions, and have been having some issues there. But we've pushed a request to update test vectors with some of the test data we need for our fork of Libras Zcash, and I guess we'll push our changes to the Libras Zcash either today or tomorrow. And Paul has started work on implementing ZSF in Zcash D, so we've plugged in our changes to Libras Zcash to Zcash D as well, and I know Paul has managed to send some transactions. I think there's quite a number of things still missing. I think transaction verification and Coinbase transaction verification I think is not updated, but in general I think things are progressing there. So Paul, anything you want to add?
I think the only thing missing now is the deposits from Coinbase transactions. And I think all of the rest, in most of the signing complexity is in Libras Zcash. But the additional field and serialization stuff is all covered by RPC test in Zcash D that seems to be working quite well.
There's still a few RPC calls, right? I think we'd have to update the get block template, I guess.
I think,
Well,
yeah, maybe just a couple left, but things like send to address and create raw transaction, those paths to depositing are covered. Yeah, I think some of the mining related RPC calls still need updates.
all right.
Aria.
What's the motivation for implementing this in Zcash D?
Yeah, so the main reason that we're doing the Zcash D implementation is that assuming that there's consensus for the ZSF, we want it to be included in a network upgrade in the first quarter of 2025. It sounds like it might take longer to deprecate Zcash D than what's currently listed on ECC's roadmap, and we don't want to impede the implementation. Like it's currently a dependency for ZSAs, for example. So if the ZSF is ready and Zcash D deprecation gets delayed until the second half of 2025, we're going to push for it to be included in a network upgrade on its own.
Mm-hmm. Okay.
Any other questions? Do you want to say something, Zara?
I was going to say, well, I was certainly hoping that we wouldn't need another network upgrade in Zcash D, but I mean, it does depend on the timing, so I can't really give a very certain estimate of when ZSAs will be merged.
Aria?
That sounds good. Do we have an idea of how substantial those changes are going to be and what the review burden will be like?
I mean, so it's a transaction version change, which has some overhead. Yeah, it's not a particularly complicated upgrade apart from that.
Yeah, in terms of
notice I'm not giving an estimate.
in terms of lines of code changed directly in Zcash D, it's not huge, and I'm certainly working to keep it minimal. I think librust Zcash is where most of the complexity is. So yeah, we're trying to keep things easy to review.
Yeah, I guess that those changes would be necessary for Zebra anyway, I imagine. The ones in the Zcash.
I can
actually maybe not. Carry on.
I could upload our current Zebra code, which I think is mostly complete. So, in case you want to have a look.
Thank you.
Any other questions? Okay, let's move on to ZSAs.
Hi, everyone. So yeah, for the ZSA update, I'd like to start with Zebra, I think, today. We've helped review the lockbox funding streams PR for NU6 and Zebra some time ago, and I think we gave some suggestions there. We've also made various changes across the different crates, Libra Zcash, Orchard, Zcash test vectors, and so on, to support the V6 transaction format. Hope that involves some refactoring to move back from V7, which we thought it would be. So maybe if there is a ZSF update and we have to go back to V7, there may be some stuff there eventually again. But anyway, yeah, so right now I think all of our dependencies have backward compatible versions that support both the vanilla Orchard and the ZSA versions together. So our push now is to get like all these changes supported properly in Zebra, which is basically top of the stack. I think we've shifted to having like our version of Zebra depend on like our dependencies instead, and like made the necessary interface changes. We've made various placeholder changes to add NU7 over the NU6 changes that are there. We've picked some arbitrary activation heights for now, and we'll have to change that to whatever is agreed upon whenever. Yeah, we are working on adding functionality to inside the NU7 pieces, such as like verification of transactions and updates to the global state that is required to be stored. Let's see, we've also built a test setup to run the ZSA additions that should run via a Docker image, and we'll use our Zcash transaction tool over a Zebra node. I think that's under review right now, but we'll post an update when we have that up and running. On the further implementation, we completed making changes based on Strad's review to Zcash node encryption. I think some of the changes create some interface changes in Orchard and Sapling Crypto. So we've made those changes in those crates as well, but I think we've not pushed PRs to upstream so far. But we have that ready to support the changes to Zcash node encryption. On the zips front, we've merged, we basically caught up to the upstream changes that came due to the NU6 and the restructuring of the repository. So we've merged those changes into our changes, and yeah, basically things are clean and look simple to merge once again. We've also been responding to various open issues about ZSAs that are there on the zips repo. I think there are still maybe 2 or 3 that are open, and I'm working on those. Strad, I think Strad had previously mentioned that the asset swap zip, once it has been moved to the new format of after the restructuring, that could be merged into upstream. So I will make one pass over it still, and then I'll probably send a message on the zips channel in the Discord, and yeah, let you know when that's ready to be merged, so that it's available upstream for people to comment on and have a look at in more detail. So yeah, to sum up, our main focus right now is tying up the loose ends in Zebra and Libra Zcash and the test vectors to make sure that we have a working ZSA version for the community to play with as soon as possible.
Any questions for Vivek? Okay. Moving on to Frost. I think it's Conrado today.
Yeah. Yeah, we've been working on our Frost server, the component which we created to help people run Frost, and we've been adding encryption, communication, and authentication for it. And this is basically the last piece we need until we have something that we are confident people can use securely. We're also thinking of doing an audit after that, but we've been working on that. There's a permanent design going on, and I started implementing it, and then I realized that there's some tricky aspects to it. It's just always the key management is like how you register people's public keys, how you bind them to identifiers, stuff like that. We're still figuring this out, but yeah, the implementation is underway, and I think yeah, it shouldn't take too long. But yeah, I think that's basically the last thing we need. We still haven't published 2.0 of the Frost crates. No particular reason for that, just waiting for more feedback on the RC release. And I think that's it. yeah, we still need to finish we did the refresh share functionality for the trusted dealer, but still working on the DKG. And that's it.
Any questions relating to Frost?
Oh yeah, I have a question. The server, when do you think it would be ready to undergo an audit, time-wise, not just relatively an estimate, ballpark estimate, not like
Yeah, yeah.
seconds and minutes.
Yeah, also we finished the encrypted authentication. There's a few loose threads that we might want to address, just, like stuff that we postponed, which is not hugely important, but we might want to finish. But that's the last piece. So just a rough estimate, like 1 month, maybe 3 weeks, 1 month, something like that. Yeah.
Okay, has the Gordian developer community contacted the Frost?
Yeah, we had a
Team?
meeting some time ago. And I think there will be another meeting in September, if I'm not mistaken. But yeah, the work they have done so far is mostly related to how to store and backup and the shares, right? Which is something that is important, but I don't think it's the biggest blocker right now. But yeah, I think we start reaching out to them to see if we can combine efforts on that regard. But I don't think it's a blocker for what we've been doing.
Cool.
So I noticed on the zip PR that is about I think it's updating the use of randomization.
Yeah.
I suggested a way of generating the alpha value that doesn't depend on the doesn't fully depend on the coordinator's RNG.
Yeah.
So you might worry, for example, that it's been compromised or it has some stupid seeding bug like RNGs have had in the past. And so it seems to me that that's a useful change that doesn't increase the number of rounds.
Yeah. Yeah, I saw that. That's a great suggestion. At first we were considering doing the signing package, which is the commitments plus the message, but then realized that
Yeah, you can't
randomizer
use
is
the message in this.
is the inputs
You
to
can,
generate
yeah.
message.
You
But
could
yeah,
use the PCZT
yeah,
if there was a standardized format for it that just excluded alpha, maybe. But I don't think it's worth it. I think you
yeah,
gain all of the benefit by including all of the commitments because
yeah,
those are random from each participant.
yeah, yeah. That was a great
And
suggestion. I'm going to update
yeah.
zip. Yeah.
Okay, thanks.
Just for regarding zip, I think I opened another PR, which is basically has a sketch, right? I think the biggest piece missing in the zip is how we generate the Zcash wallet, the key tree, the rest of the key tree, right? When you use a Fast wallet, and it has a couple suggestions to how to do that. Not even suggestions, a sketch of something just to start the discussion. But yeah, if anyone who is interested in that, please take a look on that PR. So yeah, we can
I'll have
find a way to standardize a way to generate a Frost wallet. Yeah. That's it.
It's 883, isn't it?
Yeah, I think so.
Yes, it is.
Yeah.
Cool.
Any other questions relating to Frost? Okay, let's move on to trailing finality. I think Zuko was going to provide an update. Do you want to share your screen or anything, Zuko?
Well, I have this is my phone and I have notes on my laptop, so maybe I'll just read them. So I can't figure out how to share it. Well, I'm not really going to read them. I'll just talk from them. So how much longer do we have for this meeting? And is there anything else we want to talk about?
We have 38 minutes scheduled, and the only thing we have after this is announcements and an open discussion.
Okay. Well, that's way more than enough time for this. Maybe we can use some of the open discussion. So we are here to accelerate the deployment of Crosslink at Shielded Labs. The current focus is collecting and documenting desiderata / requirements / non-requirements and trade-offs among them. And the other thing that we expect to start soon, as Jason might mention after this, is implementing the dumbest possible prototype that would be informative to learn from. So my goal here is to stimulate you folks, and then separately the broader Zcash community, to help enumerate the desirable features of a Crosslink v1 deployment. First of all, why do hybrid proof of stake at all? Here's our motivation at Shielded Labs. There's three main motivations. First is that it increases the demand for Zec coins and reduces the supply of Zec coins on the market. Increases demand by giving people something else, some additional new thing to do with their Zec coins, and it reduces supply because Zec coins that are locked up for staking can't be sold on the market. And so both of those exert upward pressure on the price of Zec, and that's good because the price of Zec is the fuel for our mission and it attracts users. And the second is that Crosslink v1 adds finality that protects users from getting robbed, and it is necessary or at least super helpful for cross-chain bridge things like the Avalanche bridge that's currently in progress. And the awesome thing about the Crosslink design, due to Nate and Dara, is that it's a kind of defense in depth where basically this might be overstating the case. I'm not sure, it might not, but basically if you want to harm Zcash users who are relying on Crosslink for finality, then you're going to have to break both proof of stake and proof of work, or the implementations thereof, in order to accomplish that. That's awesome.
I can detail the caveats to that if you want, but let's leave that for the discussion.
Okay. And the last motivation for deploying Crosslink v1 is that it's a foundation for future improvements. I imagine that it will make it easier and safer to deploy other improvements to Zcash consensus protocols, such as cross-chain communication and scalability improvements. I'm not sure about that yet. That's also something that I might be interested in hearing about during the discussion. But here's the initial list I've sketched out about goals or desirable features. And so the main thing I want is either in this right now or in the open discussion or in the Discord channel or something. Help me notice missing desirable possible features of Crosslink. Okay, first of all, I'll just read this off quickly because you probably know most of it, and then we have plenty of time for discussion. Here's my list. Number one, can users stake or delegate their Zec and get rewarded for doing so, and what risks and costs to them do they incur thereby? Number two, can users run their own validators if they want to avoid those risks and costs or support the network? Number three, time to market. When can the users start doing this on mainnet? Are we talking first half of 2026 or earlier or later? Number four, safety, which is a big category that encompasses all kinds of things: reliability, privacy, availability, and safety. Number five, user experience in terms of a couple things: ease of use, safety, reliability, availability, user experience. And then the other one on my list is simplicity of concepts for users. If you're a Zcash user, you want to stake your ZEC and get rewarded for doing so, but you don't know about the existence. You don't know what a validator is. You don't know what a proof of work means. You don't know nothing. What's the fewest things you can learn in order to correctly do what you want to do, which is stake your ZEC?
So numbers go up, basically.
Well, you got to learn a few things. Like, you got to learn what the risks are for starters, right? Like, is this free money you're getting or what? So yeah, this is a open part of this, is what's the set of things that the users do have to learn, or what does their wallet have to do for them? So anyway, that's what I've written down on this list, is simplicity in terms of concepts the user has to learn to do what they want to do. Next, latency. And Nate pointed out something really cool to me, which is that I was saying to Nate at some point, well, Crosslink V1 is awesome for safety and ease of deployment, but it does nothing for latency or performance. And Nate pointed out, oh, I wonder if I could load it up. There's this awesome new wiki page from ZecHub Wiki that has all the centralized exchanges and how many minutes you have to wait if you deposit your ZEC into them. You should definitely look at that wiki page. I can, yeah, I can post it into the Discord later or something. But the answer is you have to wait a long time, and you have to wait a very different amount of time depending on which centralized exchange you're depositing your ZEC into. And Nate pointed out to me that deploying Crosslink V1 with finality, with a simple, widely understood number of block height for finality. Yeah, there we go, Jason. Jason R. I can't read that right now, Chris. I'll read it in a second. Interrupt if you want to say this right now, Chris.
No. It's that's my comment is to earlier chat. So don't.
Okay. So anyway, Nate pointed out that latency in terms of waiting for some service, such as the CEX, to accept your ZEC deposit could be greatly improved by Crosslink V1, even though latency in terms of underlying Byzantine consensus protocol isn't. So I think that's cool. Anyway, on with my list. Throughput, number of transactions that we can make simultaneously. Next, ease and gracefulness of upgrade for existing users like miners, mining pools, CEXs, instant exchangers, etc. Next, retain the advantages of existing proof of work, such as people being able to permissionlessly mine to get their ZEC, even when they don't start with any ZEC or any connection to the network, which I've heard many times over the years was really important to people. There was a time many years ago when that was widely used in Venezuela for people to acquire Zcash by proof of work mining in Venezuela. And then I haven't heard about that. I think the corrupt government seized all of their miners at some point. And then I heard about people doing that in Iran. And then recently I've heard about people doing that in Russia as of today. So retaining the ability for people to do that's a good feature and desirable property. And the last one on my list is safety and ease of deployment for future network upgrades. And then I have a little sub list. I'll send you these. I'll post this document into like the Discord or something after this. I have a little list of different types of threats to safety. It says proof of work break, e.g. 51% attack, equihash algorithm failure, mining pools and miners all get hacked, eclipse attacks, et cetera, et cetera. Next category, proof of stake break, e.g. 67% attack. The proof of stake protocol is bad, is wrong. The validators get hacked, long range attacks, et cetera, et cetera. And then the last category is implementation bugs exploited on mainnet, which could be bugs in.
Point of order, 34% is of the attacker is sufficient to break the proof of stake assumptions, not 67%.
Isn't that only to break the liveness assumption, but insufficient to break the safety assumption?
It's complicated. So if you assume Byzantine failures, in other words, you can assume that the adversary can cause network partitions, then it's
Oh, right.
34%.
Yeah, I learned this in your presentation.
Yeah. So basically, you're already assuming something stronger than that when you rely on proof of work, because all of the security analysis that's been done on, for example, Bitcoin and similar proof of work protocols, kind of implicitly assumes that the attacker can't create partitions. So that is a motivation for moving to proof of stake. So you are getting strictly better security there, but the point is that so you can't have it both ways. If you want to not make that assumption about partitions, then the attacker threshold is 34%. If you do make that assumption about partitions, then you can get away with a larger attacker threshold. And the analysis of that is quite complicated, so I won't go into it.
Right. And later, can you go into whether crosslink makes partition attacks harder? Like I kind of think the difficulty factor overhang protects the proof of stake network.
I have some good notes on that, and I will load them back into my brain. I'll just quickly read them while you're talking about other stuff.
I have edited 67% attack to 34% attack in the list of ways that proof of stake can break. And the last category, which I actually think is probably the most dangerous category for threats to safety, is implementation bugs exploited in mainnet. And that could be bugs in proof of stake implementation, proof of work implementation, i.e. the full nodes that implement that thing, or the libraries that those full nodes use, and so forth. In the light client server software, there could be safety failures there, which could harm users, even though all the full nodes are still working. And in the client software, i.e. all the wallets and all the exchanges and everyone who uses the network. Okay.
And of course, there's attack surface that isn't dependent on that layer, that isn't dependent on the consensus layer proper. Bitcoin changed the meaning of what consensus means. I'm talking about consensus in the distributed protocol analysis sense. So
what is
if for example the proof system breaks, then it doesn't matter whether your consensus protocol proper is secure.
Okay, so I'm going to put
That's an existing weakness, or an existing attack surface.
Other attack service, e.g. proof system, which may or may not be affected or worsened by the deployment of Crosslink v1. Okay, that's my presentation. I'll post my Google Doc so you can add comments into it. Next steps: gather any other missing goals, features, desired properties, etc. to add to this list. Analyze trade-offs among them. Choose scope for Crosslink v1. And in parallel with all that, as soon as we can get rolling, we intend to implement the dumbest prototype that anyone would be interested in playing with. Oh, and one more comment. Crosslink v1 will hopefully not be the last Zcash protocol upgrade. And so a lot of the desired features, like in particular, I'm thinking about high scalability, is something that we shouldn't try to squeeze into Crosslink v1, but that we're still excited about at Shielded Labs for future upgrades. Jason, tell them that we're hiring.
Oh yeah, of course. All right, so we're looking to hire a couple mid-level Rust developers to work on Crosslink. If anybody is interested or knows someone who might be interested or a good fit, they can reach out to me, best on Twitter, the forum, or you can email me at jason@shieldedlabs.net.
So to go into some nuance on the threshold of attackers needed for to break the proof of stake protocol. So it depends on what you assume about what kind of partitions the adversary can provoke. So personally, I don't think it's reasonable to assume that the adversary can't provoke partitions at all, because they can, for example, do denial of service attacks that take some nodes offline or attack the network connections.
And they haven't practiced exploited BGP routing, including to attack Bitcoin mining.
Yes, good point. In fact, BGP routing attack is one of the nicest attacks from the adversary's point of view, because that can potentially, depending on how they do it and depending on where the nodes are distributed, it can give them a good approximation to a perfect network partition where you split the network in two. But so the raw proof of stake algorithm is not the only defense we have here, because if we detect out of band that an attack like that is happening, then we can tell validators to stop validating at all, which will stall the chain, or we can agree out of band on which is the correct fork, or there are things that we can do to prevent a partition attack like that, which would presumably be very noticeable. I mean, it's very hard to do that attack without being noticed, to prevent that from sort of turning into something that is sort of easily exploitable. So I think the fact that the threshold is technically 34% in some attack models, I wouldn't worry about that unduly.
I'm going to put it back to 34-67.
Yeah.
Somewhere between 34 and 67. By the way, channeling Nate, I kind of think the proof of work component can help with this.
Yeah.
In part because of the difficulty factor can't quickly fall. And maybe also, this is the part about channeling Nate, something about the proof of work serving as a beacon or a shelling point for the social coordination among the stakers.
Yeah, remember that you are assuming that lack of partitioning in the proof of work as well. So yeah, there are attacks against proof of work that are not normally considered because they assume so. Yeah, the dependence on the attack model that you accept rather than so proof of stake protocols came out of the academic community, where the spies and time failures model was a very nice abstraction, because it's making very weak assumptions and you can prove interesting things about it, and you can make a split between synchronous and asynchronous protocols. So it's very, very nice to write papers about. And I think maybe some of that, it being nice to write papers about, was kind of an obstruction to making real world progress. And this is the insight that Satoshi had, really, that it was okay to assume a weaker model. But nevertheless, it's very nice to have this resistance to partitioning attacks because, as you say, some of them are quite realistic. So yeah, it's nice to have both types of security.
Before we continue with this discussion, can I just give anybody who wants to an opportunity to make any announcements if they want to stick up their hand. Josh Swihart has raised his hand. Should be able to talk now, Josh?
Yep, can you hear me?
Yep.
Just something real quick that might be of interest. I spent some time with Iran Barak this week. So we sat down and talked about the project that he's working on called Midnight, which is part of IOHK, so the Cardano community. So they're using Halo 2, and he said that they're about done adding recursion, and that then they're going to upstream that code as soon as it gets through audits. So he's saying, he's claiming that they'll be done by Q4 this year, and then they'll go into audit, and that audit they expect to take 3 to 4 months. And then they'll upstream that code. So we may have it sooner than later. We'll see what happens. But one of the things we wanted to do was to get some of their team kind of connected with the core teams here, so we can see what they have and dig underneath the covers a little bit. That was it.
Okay. Any other announcements?
Maybe follow up on that as a question. Once you have this, how feasible is it to go over all the past transactions and kind of prove everything all the way to now so that you can bootstrap everything immediately?
So the issue there is that yeah, the issue there is that the transparent protocol would be hugely complicated to prove anything about.
So drop it. Drop it.
Yeah. You can.
Oh, no,
so
you can't because it goes back and forth.
You partially can. So what you can do is precisely because it's transparent, you can verify that once, and if there's social agreement that all of the transparent stuff balances, then you can take that as an input to your proof about all of the shielded stuff. And so, yeah, you could definitely do that. The other issue you would have is that, so say you're doing this using Halo, it's easy to prove stuff about Orchard because you're on the same curve cycle, but proving stuff about sapling is hard because that would require non-native field arithmetic. So again, if you're prepared to just accept that all of the sapling stuff is okay, in other words, if you're using this as a performance improvement rather than a sort of, we want to know that all of the proofs are correct for an assurance, from an assurance perspective, then yes, recursion is obviously very useful, and that's why we added it to the protocol. Well, that's why we chose the pasta curves for Orchard. Yeah, but proving everything from Genesis, which obviously includes Sprout as well, although is hard.
Thanks.
And very inefficient. But if you, for example, at some point we could deprecate sapling, or we could say, in the same way that you can't add new funds to Sprout, we could do the same for sapling and say you can only withdraw funds. And then that would limit the potential balance violation, even if there were a weakness in GRUT16, say, or the way we've implemented GRUT16, more likely, that you could bound that to what's currently in the, or what is in the sapling pool at the time that you stopped new additions to, in the same way that we have for Sprout.
Any other announcements anybody wants to share or news? If not, we'll go back to open finality or whatever else people want to discuss. Jason.
Yeah, I have one thing I wanted to bring up for ZCG. I wanted to flag a grant for node implementers and ecosystem engineers to review, especially those focused on Zcash D deprecation. Zonkis is requesting $76,000 to help accelerate the deprecation of Zcash D by implementing key RPCs for ZebraD. And the RPCs are an RPC method for listening to change tip changes, listening to changes in the mempools, and getting a new nullifier for block hash or height. And so basically ZCG just wants to know that these actually will help with that effort, and that the grant amount is reasonable.
Okay, I'll have a look at that when I've got time.
Thank you.
So what's the timeline on that?
Our next meeting is, let me just pull up my calendar, on the 2nd of September. So if before then, that would be ideal.
Yeah.
Alfredo?
Yeah, so those RPC methods that they are trying to do as part of the grant are part of the indexer task that we want to do in Zebra, which is mainly ARIA. In that side, we defer it for now for the new SIG stuff. So yeah, I think the best person to answer that will be probably ARIA.
Let's hear from ARIA.
We are hopefully meeting tomorrow to discuss the details and scope of that project if anyone else wants to join. But I don't have too many details to share yet.
Yeah, I'd like to join if you might invite me.
Sure. I'll add you to the Signal group.
Thank you.
Is anyone else interested?
You can add me to the Signal group as well.
Sure.
Yeah, please add me.
Okay.
Cool. Well, let's return to open discussion if people want to continue discussing Crosslink. Or recursion.
I posted the link to the document. Please contact me on Discord or whatever, or add notes to the document about other things that we might want in Crosslink deployment.
Oh, I said I was going to mention caveats. So we've mentioned some of them with the threshold of how much the network and attacker needs. But there's also the fact that the mining rewards will need to be split between proof of work miners and staking, or some way of incentivizing validators. So did you have any thoughts on that, Zuko, about the economics?
No. My main thought was, let's split it 50-50 because that's hard for people to argue about. My
Yeah, so
main
it
thought
then
is that
behaves it behaves like an extra halving, which we've done before for Blossom. So the remaining issue is the absolute amount enough?
my
on
main
each
thought
side.
is that my main thought is that the cost of buying that many miners or compromising that many miners, or on the other part, the cost of acquiring that much stake or compromising that many validators is not the cheapest way to attack. So that however we balance the split between that cost and the other cost, it's probably not gonna make that combined crosslink V1 vulnerable to that sort of like economic based attack. But this is a very half-formed thought at this point. I'm partly
I mean,
inspired
it also depends on the coin price. Because so miners and also validators that presumably have costs that they have to pay in fiat, and therefore
but the
so
payoffs are also probably go down with the coin price going down, right? Unless we have CSAs, then we have a problem in economic inequality.
Well, I'm not sure that adding CSAs is really the issue, because you're going to be able to, there's going to be a marketplace to exchange between Zec and fiat anyway, so it doesn't matter whether you can do it within the protocol or not.
Well, okay, so back up. The cost of a 51% attack, or whatever you call it, a something percent attack on proof of work mining, and the cost of a something percent attack on proof of staking, those are both what are they? They're like upper bounds on the cost to an attacker to attack, right? It's like, here's one way you could attack. It would cost you this much to attack this way. All right, so far?
Yes.
Okay. Well, the very next thing I think we need to reason about is the benefit to the attacker of attacking.
Yes.
And that's one thing which really pleases me, that I think proof of work is way more secure in a certain way than proof of stake, which is that with proof of stake, if you have somehow compromised, you can sign as many transactions as you want, right? It's basically free. So it's a multi-spend. If you can break it, you can defraud any number of participants. The protocol is not going to slow you down. It's just a question of how many victims you can defraud in parallel or over a long range attack with your keys, right? But with proof of work, the protocol can slow you down. You have to do another proof of thermodynamic expense per target victim. Isn't that cool? So proof of work, it can be limited to a double spend.
You can do attacks in parallel, but it depends on how many victims you can find within the sort of the period of blocks that you're able to roll back for. So if you have 51%, then you can roll back an arbitrary number of blocks. But of course, someone will notice and then respond to the attack.
But can't the proof of work algorithm require a given coin to be committed to as a required commitment to the thermodynamic cost? Therefore, you can't spend a given coin to more than the number of victims that you are able to generate proof of work blocks for.
Does not compute. Can you say it again?
Okay, so for a given, let's say I have the ability to defeat proof of work. For example, I have 51% of all the miners, or I've hacked into the mining pools that have 51% of all the miners, or whatever. But so now what I want to do is what has been done in practice to gate.io, when someone deposited millions of dollars worth of ETC into it, and then use their 51% power to undo the ETC blockchain and make it so they had never deposited those millions of dollars into that exchange after they'd already withdrawn the resulting Bitcoin or whatever from the exchange. Okay, so I want to do that as an evil attacker. I want to defraud people, but they are going to require to see a proof of work block with a deposit to them in it. So each of my target victims, if there's 1 million victims I want to do this to, each of them needs to see a proof of work block, and it needs to have a transaction to them in it. So if I have
it
only...
depends. It depends how much capital the attacker has. So they can basically double spend all of their capital with a single fork.
Right. So I think this is a deep difference between proof of work and proof of stake. For a given capital with proof of work, you can double spend it, but it costs you 1 proof of work block's worth of thermodynamic cost per added victim for your capital. Okay. With proof of stake, if you can defeat it, then it's free to defraud an arbitrary number of victims in parallel with your same starting capital.
Yes, I believe that's correct. And this was one of the motivations for keeping proof of work in Crosslink.
Yeah, so that's what I've come to, is that proof of work is actually really good to keep around, at least for now, for added safety. I forgot how we got onto that. You were saying something else about
the 50-50 division with the miners. But
the economic balance.
You can be more and more conscious about the environment and move it to 40, 60, 30, 70.
Yeah,
and
I mean,
as the planet stops spoiling,
if the price goes up, then you can potentially, I think, reduce the proportion that's allocated to the proof of work side and reduce the environmental cost.
Interesting.
Which is not the same as for, say, Bitcoin. So there, the environmental cost is kind of tied to the difficulty level in such a way that, yeah, the coin price going up is actually a disadvantage.
That's a good point.
From that point of view.
I remember what I was going to say earlier, but I see Paku's hand is up.
Yeah, I was going to kind of piggyback on something you said earlier when you're mentioning your desirable features and goals. And I wonder if implementing Crosslink can be an opportunity to bring back users that Zcash might have lost when it transitioned to ASIC mining, or maybe that bridge is burned, but maybe being able to attract people with that same mindset, or what you said about having grassroots miners in Venezuela or Iran, or also Argentina or other countries that they can see this as an opportunity to actually do some investment that doesn't have to do with buying from a fiat on-ramp and participating in securing the network in some way. And also how does that balance with the security? Because I wonder, I'm not a protocol expert, but I wonder if I can create a validator with just a few zennies, Zcash pennies, then wouldn't that be detrimental to the proof of stake security? And how can we balance that
good question,
to have those the cake I needed?
I've added
so if you're delegating, if all you're doing is delegating to another validator and obtaining the mining rewards, and you don't do anything to kind of keep that validator honest, then you're not actually contributing to the security of the protocol. I don't think there's any way around that. If you're running a full node and you can observe. Actually, so here's the point. If you withdraw your delegation in response to attacks that can be attributed to that validator, then it doesn't actually matter whether you did the validation or you are relying on a social consensus, as long as that social consensus is correct. So it doesn't matter how it was obtained as long as it's correct. So that's a very good point about delegation.
That is interesting. And Paku, I added your comments to the second bullet point in the Google Doc. So feel free to edit it or comment it.
Oh, thanks.
Oh, so the thing is, there's a cost to attack, and then we should be thinking about the benefits to attack. And that's tricky because somebody might get like infinite utility points, or not infinite, but they could get a great number of utility points from destroying everyone else's Zcash just because they're haters, you know, like
Yeah,
griefers.
that's the
So
attacks that I'm most worried about, to be honest.
That makes it hard to balance, but we can see huge differences if I'm right that proof of work mining allows up to double spend basically without additional cost, and proof of stake by itself allows arbitrarily large multi-spend with the same cost. And then what was my point? Oh, my point is the top-heavy problem. Because Dara said, what if the cost of ZEC goes down, the price of ZEC goes down, the cost to an attacker to defeat crosslink and or proof of work and or proof of stake goes down. But also maybe the motivation to them to steal ZEC or ruin people's fun goes down.
I mean, they can have lots of different motivations. And as you say, if their motivation is political, so if they don't want people to have private currency, and that is a motivation of several governments, we have to remember.
Right, yeah.
Then and the governments have basically arbitrary amounts of money anyway. They can print money. So
yeah, so for that attacker, this
better
kind of
hope that you
economic
don't have
analysis,
better hope that you don't have a government as an adversary, because a lot of this economic analysis breaks down with
for that kind of attacker with sort of like infinite resources to spend or infinite willingness to spend, and they're not concerned about the financial benefit to them. That's one attacker. But this conversation has made me think again about the so-called top-heavy problem, which is, what if we have ZSAs and there are transactions of 1 billion Bitcoins going back and forth, which are secured by ZEC-based crosslink, and the price of ZEC goes down 100x, and now it only costs you $10,000 to control 51% or 67% or whatever of the consensus rules. But this $10,000 consensus rules is protecting people from a $1 billion rollback attack of BTCs.
If you don't go buy a bunch of ZECs to protect yourself on your billion Bitcoin transaction, then you're a fool, right? You probably would need to dedicate some thought to the network you're using, and
you might, but there's a potential tragedy of the commons there, because you might reason that it's not your individual responsibility to support the price of ZEC.
There's some economic curve there there's some economic
the economics there is complicated.
Yeah. And the other way to look at it is, if the price of ZEC has gone down so that the cost for the economic attack is low, then you don't accept billion-dollar transactions to you of Bitcoin on that network, I guess.
Yeah.
Also, to push back on John's point, like, an attacker could be at both ends. So what they want to achieve is a huge reputational hit on Zcash and ZSAs, they can attack themselves and just profit on like trashing our network, and they won't suffer any economical
That's a very good point.
in the end.
Interesting.
Aria?
Is there or will there be a Git repository that we should be watching for updates on the exploratory implementation?
There is not yet. I will post it. Are you in the R&D Discord?
Sounds good.
I'll post it as soon as there is one.
Wait, if you're on both ends of a ZSA transaction, it's secret. So the reputation requires someone to disclose.
Well, I wonder.
Yeah.
There are a couple of governments that have seized huge amounts of crypto on when they incarcerated developers, so they have the liquidity and the manpower to do that.
I'm saying
may.
in order to collect the reputation or to do the reputation damage, you need to reveal the transaction or do some sort of.
You can use selective disclosure.
Yeah, you also need to not get caught in the sense that any reputational damage you can do will be blunted if people know that you did the attack. So, I mean, governments are good at doing attacks and attributing it to other people, to be fair.
Yes, they are.
Yeah, they're also good at finding good old ways to attack these things rather than advanced economics, right?
That's true as well.
Good points.
Cool. I thought about several new things in this discussion. I like that.
Cool. Well, we are past time, so let's wrap it up there. And our next meeting will be in 2 weeks' time in the later time slot of 2100 UTC.
And I just noticed that the Zcash D 510.0 RC1 release PR has passed tests, so I think I'm going to merge that now.
Thanks for your time, everyone.
Okay.
Right.
See you.
Thank you,
See you,
everybody.
Mexico.
Thank you.
Thank you, bye.
Bye.
Bye, everyone.